So, very quickly, since my time is up, I've talked about some of the origins of this work, producing fragmentation to make rare isotopes. Conrad's already mentioned that there was a tremendous amount of community review over the last decade. First of all, around 1999-2000, where originally the FRIB concept was first developed by the ISCOL task force. It was endorsed by the community. A few years later, it was realized that that concept, RIA, was too expensive. We then went back and reassessed it in the middle of the decade, and now we're at the point where the cooperative agreement has been signed between DOE and MSU, and hopefully about 8 years from now, FRIB will be operating. It's a very exciting time. Before I stop, maybe I just address, are there any challenges? And actually, there are perhaps some challenges, so let me just take 2 minutes to discuss that. First thing, I've talked about rare isotope research as a somewhat Michigan-centric activity, but in fact, this is a worldwide effort. This is another picture that came from the NRC Rare Isotope Assessment back in 2006. And as well as the work going here, there are facilities in Japan, in West Germany, and Canada attacking this work. And they're all engaged in various kinds of upgrade of their facilities. And in fact, in that same report, they showed a timeline for the different things. This is a different situation from the last two facilities that the nuclear physics community built, the relativistic heavy ion collider and the Jefferson Lab machine. In those cases, they were the only ones in the world. In this case, FRIB will be part of an international effort to study this science. These machines are all different. They each have their strengths and their weaknesses. They're complementary. So this is a great thing. But in reality, science is also a competitive business, and it's really important that FRIB, when it comes on fast. Out here in 2017, it's going to be a little bit after some of these other upgrades and major facilities. And so there's a challenge here, I think, during the next few years, both for the management of the laboratory, for the two agencies that are involved in this project, the National Science Foundation, which runs the existing facility, the NSCL, the DOE, which is building this new project, the university, which has supported it so generously, and the user community, to all work together so that the transition from what we have today to what's coming in 2017 is smooth, and that on that day, we have the best possible instrumentation in place to do the experiments that are best suited to the FRIB facility. And I say that the reason I brought this up is that at the time of this reassessment that took place in the middle of this decade to decide what to do when we had to scale back the scope of RIA, scientists, they always tend to focus on how do we get back what we've lost rather than the positive parts of what we can do. FRIB can do great things, and if we focus on that, it will have a great future. I showed you a picture of the machine, but I thought I would just end with showing how it fits into the campus. We're sitting over here. The injector will go under here. This is going to be quite a transformation. There's going to be a lot of construction work going on here over the next few years. But I hope I've been able to communicate to you the excitement in the nuclear physics community, the astrophysics community, for the end result. And I hope very much to be able to come back here in a few years and see yet more change and see the first operation of FRIB. Thank you.